So section 4.4, sorry, is all about recognizing different types of things that we can factor. So these are three very unique and distinct things that we are going to use to factor. They're called the difference of squares, sum of two cubes, and difference of two cubes. You can only use this when it is in the form of something, I guess something like this, where we have a number plus or minus a number. So there can only be two terms. And I'm going to put terms in quotations because it necessarily doesn't even have to be a term. It's just a number something. So if you notice, all of these are in the same form. It's something plus something or something minus something. So on all of these cases, there's just two things that we're going to use. All right, the difference of squares is if you recognize something as a square minus a square, you can factor it into the square root of one of those things plus the square root of the other and the square root of the other minus the square root of the other. So basically what I'm doing is I'm looking over here and I'm going to recognize the first thing as a perfect square and I'm going to take the square root of it. I'm going to recognize the second thing as a perfect square and I'm going to take the square root of it. So like 4x squared, I'm going to take the square root of that. The square root of 4 is 2. The square root of x squared is x. I'm going to do the same thing with 81, y to the 4th. Oops. I'm going to square root it. The square root of 81 is 9. And then the square root of y to the 4th, the easiest way to do this is to say y to the 4th and then divide that 4 by 2 to get y squared. So this would end up being 9y squared. So my first term, the square root is 2x, and my second term, the square root is 9y squared. So I'm just going to put those next to each other, 2x and 9y squared, and then 2x and 9y squared. And I'm going to put a plus in one, and I'm going to put a minus in one. And this thing is completely factored at this moment. That's what this is. So the difference of squares is specifically just designed so that all we have to do is notice a pattern and then plug the things into the pattern. That's it. All right. All of these work the same way. You just have to recognize if they're squares or cubes. So you either have to be able to take the square root of them or the cube root of them. All right. So this one, the sum of two cubes, sum obviously means plus. So if you recognize something to be a perfect cube plus something else that is a perfect cube, this formula is a little bit different. It looks like this. It's a plus b, and then a squared minus ab plus b squared. Now, I'm going to write down the other one at the exact same time because they're almost identical to each other. The only thing that changes is the sign in the middle. So the only thing that changes is the sign in the middle. Everything else stays the exact same. It doesn't change anything else. It's still a then b, a squared, ab, b squared, and then the minus and the plus just switch. Some people, what they like to do to remember this formula, if you have to remember it, which you obviously wouldn't have to because you're remote, so it doesn't matter, they use the acronym SOAP, where they say that the first one is the same, so the symbol is the same, plus, plus. Then we have the opposite, so this one's a plus, this one would be a minus, and then always positive, always positive. So same, opposite, and then always positive. So same, plus, plus, opposite, plus, minus, always positive, so plus. Same, minus, minus, opposite, minus, plus, always positive. So that's if they want to use that, you can. If you don't want to, you don't have to. So that would be something like on the SAT. If you don't have that on the SAT and they ask you to do something like this, you have that little trick to help you remember. All right, so again, what we're going to do is we're just going to try this right here. I'm going to take the cube root of 27x to the third. So I'm going to take the cube root of this. The cube root of 27 is 3. And then the way that I figure out this little exponent right here is I just divide it by the root. So 3 divided by 3, which is 1. So it's going to be 3x. I take the cube root of 8. The cube root of 8 is 2. So now I just plug this in for a, and I plug this in for b, and then I have my formula. So it's going to be 3x plus 2. And then I'm going to put this whole thing in parentheses, 3x squared minus 3x times 2 plus 2 squared. And then that will turn into 3x plus 2 times 3x squared is the same thing as 9x squared. 3x times 2 is going to be 6x, so minus 6x plus 4. Now, the nice thing about this is 99% of the time, this is 100% factored for you. So once you realize that it is completing the square, I'm sorry, a difference of squares, a sum of two cubes, or a difference of two cubes, once you realize that, it's already going to be factored. 1% of the time, it is not going to be factored for you. And that time is, we'll go through an example. But what you can see right now is that it is fully factored. There is nothing that we can do to factor this thing back here anymore. There's nothing we can do. All right. So let me go through. Is everybody okay if I erase this? Does anyone still need it? So let's go through the second one. So the second one is a difference of cubes, which obviously you should be able to tell means there's a minus sign. So I'm going to take the cube root of x to the third, and I'm going to take the cube root of 1,000. So those are things that you have to be able to recognize yourself. If I take x to the third, I divide the exponent by this number, which is x to the third divided by 3. So 3 divided by 3 is 1. The cube root of x to the third is just x. The cube root of 1,000 is just 10. So now I'm going to plug those into the formula. So I'm going to get a minus b times a squared minus a times b, which is going to be 10 times x, which is 10x, plus b squared. 10 squared is going to be 100. So if you're wondering where I got those, I got them from x minus 10, and then x would be squared minus x times b plus b squared. That's where that came from. And this is all difference of squares and difference of cubes is. That's it. That's all it is.
Wait, wouldn't there be a plus because?
Yeah, sorry, thanks. Good catch. Good catch. All right, so that is what difference of squares, difference of cubes, and sum of cubes looks like. You will not be able to do difference of squares and difference of cubes and all that stuff on something if it has more than 2 terms. So if it said like x squared plus 2x plus 3, we can't use this. We can only use this when it's a squared plus b squared, or a squared minus b squared, a to the third plus b to the third, or a to the third minus b to the third. That's it. Let me go through another example or two, and then we'll call it good for today. So hopefully that was something that was pretty quick. So what I'm going to do is I'm just going to kind of run through this, and then I'm going to tell you that I want you to keep trying this on your own. Okay. So let's start out with one like this. So the first thing that you should do, because there are a couple checks that you should do before you get to what you're really working on. What you should check before is you should make sure that you don't have something that shows up in both of these terms. So see how I have an x to the 7th here? There's 7 x's here, and see how I have an x in here? I'm going to factor one of those x's out to the front. If I look right here, I have a 54, which means that I could pull out maybe a 4, maybe I could pull out a 6, maybe I could pull out something. Here I could pull something else out. All right, so I'm going to look for the common factors that I can pull out. So I could try to divide this by 2, right? So I could factor out a 2, and I could also factor out an x. So this would turn into 27 x to the 6th plus 8. So nothing happened here, like nothing, I couldn't factor anything here before, but now that I've factored out a 2 from all of that, now I might be able to look at this and say, is this a sum of cubes, a difference of cubes, or whatever? So first off, the first thing that you have to notice right here is this is a plus sign. Plus means sum, which means that this cannot be difference of cubes or difference of squares. This could only possibly be sum of cubes. So my only check right here is 27 a cube root? And 27 is a cube root. Is this number divisible by 3? It is. Is 8 a perfect cube? It is. So what I'm going to do is I'm going to take the cube root of 27x to the 6th, and I'm going to take the cube root of 8. The cube root of 27 is 3. 6 divided by 3 is 2. The cube root of 8 is 2. I now know my a term, and I now know my b term. I'm just going to plug those in, and I'm going to leave everything else the exact same way that it was before. So 2x times. Now I'm going to, if you want to, you can put a big bracket here. It doesn't make a difference. But now I'm going to do a plus b. So 3x plus 2 times a squared, so 3x squared squared, minus a times b, so 3x squared times 2 plus b squared. And now I just rewrite it so that it's not as jumbled as it was before. So 2x times 3x plus 2 times 3x squared squared is going to be 9x to the 4th power, actually, minus 6x squared plus 4. And that thing is factored.
Wait, what happened to the square on the 3x part, like in the first full
This part right here?
equation? No, the one before it. It goes 2x, and then
Oh.
the bracket 3x. I wasn't sure if we were supposed to leave that out.
No, it was supposed to be there. Thanks. You're doing a lot of good checks.
I have a question about like this method and
Yeah.
stuff. So why are we doing all of this?
So this is just another method of factoring, which eventually in this chapter, we're going to have to be able to find zeros of functions. And this allows us to find zeros of functions very, very easily in certain cases. Now, that being said, a lot of the times that we have functions like this in this huge, crazy form, if we have functions that look like this, most of the time what's going to happen is they're going to give us combinations of functions. So they're going to make us take two functions and put them together by either multiplying them, subtracting them, adding them, dividing them, whatever we're doing. They're going to make us take functions and put them together. Once we get them into this form right here, it's going to allow us to cancel things. So it's going to allow us to cancel things out, which is going to make our life easier in the long run. So this might seem confusing and complicated and unnecessary at this moment, but when I give you 3 of these things right here and tell you to multiply them together, and then you're able to start canceling and simplifying and closing things off, it's going to make your life a lot easier in the future. So right now, there isn't a super good application for it. I'm not going to lie to you. There isn't a great application for what you're using this for. But in the future, once we start combining these functions together, we're going to start canceling them and getting rid of things, which that is going to make life easier in the future. As for real life application, doesn't exist. At least as far as I can find. Unless you're going to be an Algebra 2 teacher when you go to college. Any other questions on this? All right, so let's go through one more thing, and then I'm going to be done, and I'm going to let you guys try to practice it, and I'm not going to give you any homework or anything today that you have to work on. I just want you to try something, okay? So this one right here, we're going to work on. And this right here, if you notice, it does not look like what we just did, right? It is a 3-term polynomial, which means it's a trinomial, not a binomial. So this has 3 terms to it, and since it has 3 terms to it, that means that I cannot use the difference of squares on it, all right? But there's something that you just have to check. If you look at this number and this number, and if you notice that if it is double, then you can just factor like normal. So if it's double, you can just factor it like you normally would. The only difference is you take whatever the exponent is here, and that's what goes in your parentheses. So I would do x to the 3rd and x to the 3rd. Instead of doing it as x and x, I would do it as whatever this term is right here. But notice that 6 is 2 times what 3 is. 6 is double. I would just put this term here and then move on. And now we would factor it like normal. So now I would just go through and find 2 numbers that multiply to give me 1 and add to give me 2. And now it's +1 and +1. But now notice the fun that we can create with these types of questions. With these types of questions, now I can say, well, is this thing a sum of cubes? Or is this thing a sum of cubes? And we can obviously see that x cubed is a perfect cube. And if I take the cube root of 1, it is a perfect cube. So I know that my a term is going to be x, and I know that my b term is going to be 1. So now I'm just going to do my x plus b, or a plus b, so it's going to be x plus 1. And then I'm going to do x squared minus a times b, which is going to be x, plus b squared, which is 1. And now basically what I've done is I've made this thing into this thing. And now if you notice, this one right here is the exact same. So that just means there's going to be another set of them. So I could do x plus 1 times x squared minus x plus 1. And now this would be my factored form. If you wanted to, you could also put squares on it. So you could say x plus 1 squared times x squared minus x plus 1 squared. It does not make a difference to me how you solve that. Any questions before I stop recording?